Hello everyone, welcome to another set of notes. Today we're going to be talking about gravity. So our title will be Gravity. That should be going up at the top of your page. And below that you should be writing the essential question, which is how does gravity influence the universe? Since we are doing Cornell notes, you should be dividing the rest of your page into two columns. The smaller column is, of course, for your key points, questions, vocab, things like that. Your larger column is for your notes. And of course, at the end, you do need a summary. Since your notes are being graded, please make sure everything is there. Now, I am going to give you a fair warning. These notes are long. There's a lot of words, there's a lot of information. So I would highly recommend making sure that you are shortening, abbreviating, summarizing, putting things in your own words, all of that good stuff, instead of just copying word for word every single word that is up on the slide. So let's go ahead and get started. First of all, what is gravity? Well, gravity is a force of attraction that attracts all objects towards each other. Newton's law of universal gravitation states that every object in the universe attracts every other object. Now, you might be thinking, well, if everything attracts everything, then why don't we see everything sticking together like magnets? Well, there's a few reasons behind that, and we'll get to that in just a moment. But first, we need to talk about something else: mass versus weight. Now, there is a reason we're talking about this. Mass is the amount of matter in an object. It doesn't change. No matter where you are in the universe, your mass is going to stay the same. Unless, say, you get cut in half, then you've got half the amount of matter. So then your mass would change, but, outside of something like that happening, your mass stays the same. And mass is one of the factors that determines gravity, but we'll get to that in a moment. Now, weight. A lot of people use mass and weight interchangeably. They use it when they are talking about the same thing, but they are in fact very different. Weight is actually a measure of gravity. It measures the force of gravity on an object, and it will change depending on location. If there's less gravity, there's going to be less weight. If there's more gravity, there's going to be more weight. Now, the mass doesn't change, but the weight does. And you can see that in the diagram below. We'll talk about that a little bit more in just a moment. So what determines gravity? As I said, mass is one of the things that determines gravity. The more mass an object has, the stronger its gravity is. This is why you would weigh more on Earth than you would on the Moon, for example. Earth is quite a bit larger than the Moon. It has more mass, and since it has more mass, it has a stronger gravitational pull. Since the Moon is smaller, it has less mass, so it has less gravity. So on Earth, you're going to weigh more than you would on the Moon, and it's all because of that difference in gravity, which is completely caused by a difference in mass. Now, the other thing that determines gravity is distance between objects. The closer objects are, the stronger the gravity is. This is one reason why the Moon orbits around Earth instead of orbiting around, say, another planet, or orbiting around the Sun. It's so close to the Earth that it feels Earth's gravitational pull, so Earth keeps it in an orbit. And we'll talk about orbits in just a moment as well. So the closer two objects are, stronger the gravity is. As distance increases, gravity is going to get weaker. Right. So what keeps objects in orbit? Gravity has a huge part to do with it. The other thing that has to do with objects in orbit is inertia. Inertia is the tendency of an object to resist a change in motion. Now this deals with Newton's first law of motion, and that says that an object at rest will stay at rest, and an object in motion will stay in motion at a constant speed in a constant direction until it's acted on by an outside force. That is inertia. In the picture at the bottom of the screen, you can see a guy flying off of his motorcycle. Now, this is because of inertia. Notice he's going in the same direction that that bike was going, or that you can see the bike was going in before it hit those tires. So he's going to keep going until something makes him stop going. Whether maybe he'll hit that fence you see in the background, maybe gravity will pull him down towards the earth. But basically, he'll keep going in that same direction at that same speed until something makes him stop. That is what inertia is. So we'll talk about that a little bit more. Now, Newton concluded that inertia and gravity both work together to keep objects in orbit. So, for example, Earth in orbit around the Sun, or the Moon in orbit around the Earth. Now, as I said, when we talked about distance and its effect on gravity, the Moon stays in orbit around the Earth because Earth's gravity attracts it. Now, the Moon's going to keep moving. Everything in the universe moves. And because of inertia, it keeps moving in a constant direction and at a constant speed. But because of gravity, it ends up going in a circle. It's moving at the same speed and it's constantly moving, but the gravity of Earth is pulling the Moon towards it, so it keeps it from just going off in a different direction. Now, without gravity, inertia would cause whatever orbiting object we're looking at, it would cause it to go flying off in a straight line. It's going to stay at the same speed, but it's just going to keep going in a straight direction. And that's what would happen if we had, say, an on and off switch for gravity. And if we just switched off gravity, if we're looking at the Moon orbiting the Earth, the Moon's going to go flying off in a straight line. If we're talking about Earth orbiting the Sun, we turn off that gravity, Earth's going to go moving off into space in a straight line. So gravity and inertia are both the reasons why we have orbits. So gravity is really important to the universe, and especially to things like solar systems. This is the whole reason we're able to have planets orbiting suns and moons orbiting planets. Without inertia and without gravity, we couldn't have that. All right, now this is a long one. As I said, without gravity, you couldn't have things orbiting. Well, without gravity, you also couldn't have anything that would be large enough to cause an orbit to occur. Gravity helps to form solar systems and planets and stars and everything out in the universe. And it does this through a process called accretion. And basically, accretion is just the process of gradually building something up by gathering together smaller pieces. So, if you had, say, a round magnet, and you had a whole bunch of little flakes of metal, right? If you were to hold that magnet near the metal, all of that metal is going to, get attracted to the magnet. It's going to stick to it, and over time, over a few minutes, you might have more and more metal getting pulled to it and sticking to it. So it might get bigger and bigger because you've got all these bits of metal sticking to the outside of it. And that's kind of what accretion is, except instead of magnets, you have gravity, and instead of metal, you have clouds of materials like gases, especially hydrogen and helium. Those are by far the most common elements out there in the universe. And then you've also got things like bits of rock, bits of ice, all sorts of little things. And instead of having a magnet, you have gravity. So accretion, the process of gradually building something up by gathering together smaller pieces. So solar systems begin as clouds of materials, like I said, gases, hydrogen, helium, rocks, ice. So gravity will start to pull the materials together. And it doesn't happen real quick like if you hold up, a magnet over a few pieces of metal. It's going to take a long time. Millions of years. Just in general, things take a long time to happen. So gravity pulls these materials together, and because of that, the cloud collapses and it starts to spin. Now, most of the material, not all, but most. Okay, back to where we were before I got interrupted by the announcement system. Where was I? Okay, so most materials pulled to the center, not all. Now, as that material gets pulled to the center, you've got all this stuff coming together, and that causes the temperature and the pressure to increase. As the pressure increases, it causes the temperature to increase. Now, eventually, the pressure gets so great that the hydrogen atoms start to fuse together, and we call that nuclear fusion. And that's what causes a star, although the sun is a star. This is what causes stars to shine and give off their energy and give off light. So when these atoms, these hydrogen atoms, start to fuse together, they release energy, and that's what forms a star. Now, as I said, not all of the material is pulled towards the center, so not all of it becomes a star. Some of that material stays outside of the star. And you might have some bits of material closer to the star, you might have some further away, maybe in different areas around it. But gravity pulls those other materials together, and that forms things like planets and moons and comets, asteroids. Anything out there gets formed by gravity. So the star's gravity, once gravity pulls those other materials together and forms the planets, moons, whatever it's forming, the gravity of the star holds the planets closer to it. So that's why the planets don't just go wandering away off into the distance in space. Instead, the star's gravity traps them where they are, and inertia causes them to move. Gravity and inertia combine causes them to orbit around that star. And that's basically it. There's a diagram or a couple diagrams of basically what that process kind of looks like. And if you see in that first diagram, the tall one, you notice it says a few million years later, 100 million years later. That gives you an idea of how long these things take. So this doesn't just happen overnight. It takes a long time to happen. And that first diagram especially is really good. You can really see exactly how it works. All right. So that is it for your notes. As usual, you should be writing a summary. And that's it.